Let's look at a historic Type 1 projectile motion problem. The Enola Gay dropping a bomb on Hiroshima, Japan. In 1945, the Enola Gay, a B-29 bomber, dropped the atom bomb from a height of 9,450 meters over Hiroshima, Japan. If the plane carrying the bomb were traveling with a horizontal velocity of 67 meters per second, how far horizontally would the bomb have traveled between the point of release and the point where it exploded 513 meters above the ground? Let's review Type 1 projectile motion. Now, Type 1 projectile motion is motion from a projectile from a raised platform, and the projectile is launched horizontally. We'll call that Vx. We'll call the height dy. We'll call the distance traveled dx. There are two vectors. There's a vector that's going down. There's a vector that's going across. As if I drop the ball from height dy and I look at the vector horizontally, you'll find that there is a connection. When that ball drops, when that ball hits the ground, the projectile will also hit the ground. According to Vx equals dx tx, ty given dy is root dy over 5. And ty equals tx with type 1 projectile motion. And lastly, dx equals tx vx. Let's go back to the problem. In 1945, the Enola Gay drops the bomb on Hiroshima. However, even though it's dropped from a height of 9,450 meters, it explodes at 513 meters, which means it falls a vertical distance of 8,937 meters, and that's the vertical distance dy. It's going to have a Vx of 67 meters per second. Now, this is where the bomb is released, in the upper left-hand corner. And it's going to take the natural path. You'll notice that the Enola Gay continues horizontally. As soon as the bomb is dropped, gravity takes effect, and the bomb glides along the basic Type 1 projectile path, this parabolic shape. So it's going to drop 8,937 meters, and the bomb will free fall at the natural rate of d equals 1/2 gt squared. The time it takes to drop 8,937 meters is 42.3 seconds. So, the bomb will fall for 42.3 seconds. The horizontal velocity remains constant. Therefore, the bomb will fall for 42.3 seconds while moving forward at a constant 67 meters per second. And it'll explode. All right, let's look at this vertical and horizontal motion. You'll notice the horizontal motion, the vector for the horizontal, remains constant. It's the vertical motion that changes. When the bomb is released, the vertical vector for velocity will be 0, and then it will slowly increase at a rate consistent with gravity. And the horizontal vector will remain constant. And again, the Vy will increase according to gravity times the time along the vertical. Back to the problem. Bomb is released. There's the Enola Gay. And that's going to explode right there. Okay? And then we know how far it goes because the bomb is still going to have a horizontal velocity of 67 meters per second for 42.3 seconds. So it's going to go 2,834 meters, approximately 1.8 miles. Now, the plane will bank away, and it has 42.3 seconds to get out of the way. Now, if the plane is traveling 67 meters per second and it banks to the left or the right, it's going to be out of the way approximately 1.7-ish miles. So it's not going to be over the explosion. For safety's sake, they banked the plane to get out of the way. So the bomb will fall forward 2,834 meters. Thank you.